Java Stream API was introduced back in 2013, many engineers still struggle to understand it. For that purpose, I am creating this video series, and I hope it will get you a good understanding of the fundamentals of Java Streams API as well as what Lambda function is and how we can use that. Let us try to understand what a functional interface is. So there was a long demand for Java to be a functional programming language. So when we say functional programming language, it exactly means that we can focus more on the behavior or more on what we want instead of how do you want. For that purpose, they have come up with an idea that now we can pass a method inside another method, or we can pass a behavior to a method instead of passing value to a method. And that is achieved through an idea called functional interface. A functional interface is nothing but an interface which is having only one abstract method. If you see here, it's having only one abstract method, but it can definitely have many other static and default methods. So how is it going to benefit us? How we can use this functional interface as a Lambda function? As you can see, I have added an annotation called functional interface. So what's the purpose of this functional interface? Binary operation in DB. Let us try to create one more binary method. Binary operation, maybe make it double A, double B. The moment I am making this, I see we are getting an error. Multiple non-overriding abstract methods found in binary. So if I comment this out, what I'll see, it's working. So it means if I annotate with functional interface, it will make sure that I am not adding more than one abstract method in a functional interface. This is to avoid the accidental addition of more than one abstract method to a functional interface. You got the idea? So functional interface is optional, but it allows you to ensure that there is only one abstract method. Now let us go back how functional interface is helping us to build lambda expression. See, if I want to use this, let us try to implement that. Class, there's a binary class, class binary impl implements binary. I have to implement this. Okay. To do that, let us assume that I'm just returning the addition of these two numbers. I'm overriding this binary operator method. I'm implementing it. Now, how am I going to use this in a traditional way? So I'm going to write binary bn new binary impl. Then I'm going to write bn dot binary operation 5, 7. And if I run this, I'll see 12. So it's working. Now, how the same can be done using lambda function. Now let me tell you what lambda function actually is. Lambda function is nothing but you can consider it as a anonymous function, okay, which is implemented for an interface. So let us consider the same bn object. I'm making it bn1, and then I am going to put this method as is. It looks really awkward, right? I'm creating a reference of the interface and putting an entire function here because it's going to have only one abstract method. So how am I going to change this method into a lambda function? I'm going to remove this part. Okay, its scope, its return type, its name. I'm going to return or delete all three. Okay, and then I'm just going to put an arrow in between. That's all. It has converted into a lambda function. So how lambda function is actually, how does it look? It doesn't contain any scope or return type or name. And between the arguments and the body, there is an arrow that makes it a functional interface. Now let me comment this out first, and let us try to use it. bn1 dot binary operation. Let us make it 8 comma 9. Let us try to run it. You see, we got the number. Can we further squeeze it? Let us take the same thing. Let's make it bn2. Now it tells us that we can even remove the input types. Okay, let us see if this works. Come on, this out. We see that it's still working. So if you can see, the actual method is converting into a very narrow strip thing, okay, which actually taking only input variable names, even no type, and the operation which you have inside. Let's see, can this further be stripped? Let us make it bn3. Okay, now if you know, in case of for loop or if condition, if there is only one statement, we can even ignore this curly braces. So let us try to do that. Sorry. In this case, when you are Removing the braces, we don't even have to pass this return. What it will do, it will execute this operation, and whatever it gets, it will return. So let us try to see if this is working. bn3 dot binary operation 1223. This out first. You see it is giving 35. So you got the idea that this method is finally converted into this narrow piece of thing. Actually, this entire class implementation is finally converted into this one line of code. This is what Lambda function is, and how this is reducing the entire effort of writing code and making it more focused on what do you want instead of how do you want. It's removing boilerplate codes, it making programming code concise, and it's making it more expressive. This is functional way of programming. Okay. Couple of more things to explain here. So I have one more thing. No operation. Let's say, let us try to implement it directly. No operation is a class functional interface. It has only one method, but it's not taking any argument. So how are you going to do that? No operation, no op, and then no argument. So I'm not passing any argument here, and I can just sys out something. Is it expecting anything in return? No, it's not expecting anything in return. I'm not returning. I'm not returning anything. Let us see if this works. Okay. No dot just display. Let me comment this out. I'm not returning anything. You see how fantastic the line has become. Instead of having something like this, it has come down to this. So we have tested with two arguments. It is going to be very similar if we have more than two arguments. And if it is no argument, it's going to be like this. Now I have one more, unary. So it's having only one argument. Let's try to perform this too as a functional, sorry, as a lambda function. So what I'm going to write, unary un, then I'm going to pass one argument a, and what am I going to do? I'm going to, maybe I'm going to return the negative of it. I'm just returning minus a. Will minus a work? I'm not sure. Let us see. Okay. So un dot unary operation 70. Okay. Just commenting out this part. You see minus 70. This is a special case where we can strip this lambda function further. If it is having only one argument, let us try to copy this thing. only if there is one argument. If it is only one argument, we don't even have to give this brackets. That's all. Input, output. That's all. Make it even one, and here we pass here one. Let me comment out this. So you see how it has stripped down to this level. If there is only one argument, you don't even have to provide the brackets. You can write things like this, and also you can write things like this, where you have declared everything. You have declared input types, you have put them into brackets. But remember, when we can remove the brackets, only when there is only one statement. If it is more than one statement, you have to have this brackets on. Okay, that's all at a high level what lambda function is. Now we will see how lambda function works with respect to Java streams. For that, let's move to the next video. Until then, bye bye.